All right, AP is sample exercise 3.41, calculating molar mass. Calcium carbonate, which has the formula of CaCO3, also called calcite, is the principal mineral found in limestone, marble, chalk, pearls, and the shells of marine animals such as clams. You have two tasks. Calculate the molar mass of calcium carbonate. Secondly, a certain sample of calcium carbonate contains 4.86 moles. What is the mass in grams of this sample? And what is the mass of the carbonate ions that are present? I'm going to press pause now because here come the solutions. First task. Calcium carbonate is an ionic compound composed of calcium ions and carbonate ions. In 1 mole of calcium carbonate, there is 1 mole of calcium, and there is 1 mole of carbonate ions. The molar mass is calculated by summing the masses of each of the components. My 1 mole of calcium ion, 40.08. Again, get that from the periodic table. Now, you're not going to find the molar mass of carbonate on the periodic table. You're going to have to break it up into its component elements, which are carbon and oxygen. There's 1 carbon atom, 3 oxygen atoms. You can see that from that subscript right there. Using the molar masses given to you by the periodic table, generate the mass due to each constituent element, total them up, and that is the molar mass of calcium carbonate. Moving on to the second task. The mass of 1 mole of calcium carbonate we just found to be 100.09 grams. So the sample contains nearly 5, the sample given to us by the problem is nearly 5 moles, or which would be very close to 500 grams. So let's keep that in mind as we're moving forward. If we get a number that's not very close to 500 grams, we know that we've made a mistake. If it is fairly close, but maybe a little bit less, okay, we'll know that we're on the right track. And so we take the moles of calcium carbonate, and again, that was given to us by the question. We use the molar mass of calcium carbonate that we just calculated, cancel out moles of calcium carbonate, leaving grams of calcium carbonate. That is a mass of 486 grams. So that's the mass of the calcium carbonate present. Now to find the mass of the carbonate ions, the CO3s, present in this sample, we must realize that 4.86 moles of calcium carbonate contains 4.86 moles of calcium ions and 4.86 moles of carbonate ions. And so we simply need to calculate the molar mass of carbonate. Now carbonate, like we just did in our previous calculation, is made up of 1 atom of carbon and 3 atoms of oxygen. And so we can easily calculate the mass of 1 mole of carbonate to be 60.01. So because our sample has 4.86 moles of carbonate ions, we can use the molar mass of carbonate as a conversion factor to cancel out moles of carbonate, leaving us with grams of carbonate and a final response of 292 grams of carbonate.